we're going to hit these other derivatives that were on the formula sheet.
Should we get our formula sheet out?
You can. I'll just show you where they are. You need a formula sheet. Yeah. Pass that over to Walker. This over to Reese. And you need to.
I appreciate you. You know, I had Miss Clark and Matthew Wayne.
Okay. All right, here we go. So we're going to fill in these other derivatives that are listed on here that we have not discussed yet. So I'll just kind of refer back and show you where those are once we talk about them. So these are just pretty much rules that we have to memorize. Do you remember the day that we looked for the graph that was its own derivative? Do you remember which function it was? E to the x. Okay, so that's the first one that we're going to talk about today. So the derivative of e to the x. The derivative of e to a function could be written like this. Derivative of e to the x is e to the x. Okay, but look at this. Derivative of e to the u is e to the u du dx. What is this right here? Chain rule. It's saying, hey, don't forget to take the derivative of the exponent if it has one, or other than 1. Okay, so here's first example. Take the derivative of y equals e raised to the x plus x squared. Okay, derivative of e to a power is itself. So the derivative will be e to the x plus x squared. But then chain rule, take the derivative of the exponent, which is 2x plus 1. And I would add some parentheses around there. Okay. All right, so example 2. Y equals e to the negative 5x. The derivative of e to a power is that. So here we go. We've got e to the negative 5x. But then take the derivative of the exponent, which is negative 5, and I just move the negative 5 in front. And that's it. So those are always pretty easy. It is its own derivative. Okay, so look at these 4. What looks the worst? 4? Okay, let's do that one together. All right, so dy dx, or y prime. Okay, so anytime I see e to a power, first part of the derivative is that function all over again. But then I have to multiply by the derivative of the exponent. So that's really x to the 1/2, right? So what would the derivative be? Okay. All right, how else could we maybe clean that up a little bit? Okay, move this to the bottom, so that would be square root of x. What about the 1/2? The 1 will stay up top, but the 2 will be on the bottom. So 2 square root of x denominator. What is up top? Just that 1 and e to the square root of x. Question. Do the square roots of x cancel? No, that one's an exponent. If it was a coefficient, then yes, I could cancel those. Question? All right, so you're going to finish these out. Do you need a product rule on number 3?
No, because the x
Yes.
is
The x is a function.
E squared is what?
A number.
A number, right? E is like 2.72, so e squared is just another number. So you can use product rule, but when you get to the derivative of e squared, since that's a number, it'll be 0. Or just think of that as a number times x. So what would the derivative of that term be? E squared. Like if it was 3x, the derivative would just be 3. So that's a number times x. The derivative will just be that number.
What about the square? It wouldn't be like, you wouldn't bring that out.
Because that is just a number that's multiplying it. Drop the number in front. Drop it as in bring it down, or drop it as in make it go away? No. Just like, what's the derivative of 5x? 5. There's just the number that's the derivative. So what's the derivative of x times e squared? No. E squared. Think of it as e squared times x. So e squared is the number in front of x. Okay, on your formula sheet, the derivative for e to the x is right here. So derivative of e to the u is e to the u du dx. Okay, so that du dx is your reminder to take the derivative of the exponent. Okay, next one that we just have to know and learn is the derivative of a to the x. A is a number. Okay, so e was a number. This is when you have a number that's the base that's not e. So like 2 to the x, 4 to the x, 10 to the x. Okay, so it's a constant, a number, raised to a function that we're dealing with here. Okay, so this is how we take the derivative. For a greater than 0 but not equal to 1, the derivative of a to the u is a to the u, natural log of a, du dx. It's just part of the derivative. These we're just going to memorize. Okay? So we're going to think of them as formulas that we're going to memorize. So what is a? A is the base here. So you have a to the u, natural log of the base, then take the derivative of the exponent. Okay, on your sheet, it is here. A to the u of x is a to the u of x, natural log of a, du dx. Okay, so let's put this into practice. This is my function, 2 raised to the x, subtract 3. So 2 is the base, right? The derivative is 2 to the x, that's the a to the u part, natural log of 2, that's natural log of a, and then du dx, that's the derivative of the exponent. Well, my exponent is just x, so that derivative is 1. And then move on to the 3, the derivative of 3 is 0. And so I would just leave it, 2 raised to the x, natural log of 2. Okay, next one. It's a constant raised to a power of x, a function of x. Derivative is that, same thing again, 10 raised to the x squared minus 1, times the natural log of the base, which is natural log of 10, times derivative of the exponent, which is 2x. And there's really no simpler way to write that. You could rearrange the order of it if you wanted to, but I can't make it like 20 raised to a power. Yes?
On the test, will it tell us when we're finding the derivative page that?
You will just have to recognize it. They'll get easy. Okay, what do all of these have in common right here? What's the one thing they all have in common?
Y equals.
Okay, other than y equals.
They're all raised.
Yeah, it's a number raised to a power of x. The base is just a number, and it's not e, right? Okay, so when I see that, a number raised to a power of x, there's your rule. And that's going to remind you, okay, it's that same thing again, natural log of the base, and then don't forget to take the derivative of the exponent. Okay, so which one looks bad here? 6? Okay, let's do 6. All right, so looking at your rule, and it's at the top of the paper too, a to the u, that means bring this same thing down, 3 to the cosecant of x, times natural log of a. Well, a is your base, so that's natural log of 3. And then du dx, that's reminding you to go back and look at the derivative, look at the exponent and take its derivative. What is the derivative of cosecant? Negative cosecant cotangent. Is that a good way to write that? No, because I see that as subtraction. So let's put that in parentheses. I only thing I might change is put the negative in front of all of that. I think I'd probably just leave that.
Now
Okay.
I realize.
So it's just a formula, really, that we're putting into action. Right, when the exponent involves x and the base is just a number. Okay? And the previous one's easy because it's always e to a power.
Yeah.
Okay, so let's see what the next one is. The derivative of natural log of a function. Okay, so here's our rule. The derivative of ln of u is 1 over u times du dx. So 1 over whatever is sitting here, and then take the derivative of that thing. Okay, so first example, natural log of x cubed. Derivative is 1 over x cubed times 3x squared. And these can generally be simplified, because I can make that 3x squared over x cubed, and then that reduces to 3 over x. Okay, next one, natural log of 10 over x. Or that's the same thing as 10x to the negative 1. Okay, derivative is 1 over this, and then I need to take the derivative of that, which is negative 10x to the negative 2. Okay, so let's talk about rewriting this. What can I do with x to the negative 1? I can move it and make it positive, so that becomes x to the positive 1 up top. This x to the negative 2, I can move it to the bottom, and it becomes a positive 2. Well, I had a negative 10 up top, and I have a 10 on the bottom, so those cancel. The x's cancel, reduce, and I'm left with just negative 1 over x. All right, which one looks bad down here? 10? Natural log of natural log. Okay, so let's first of all think of this as the u. So the derivative is 1 over u, and then take the derivative of u. Okay, so derivative will be 1 over natural log of x times the derivative of natural log of x, 1 over x, times derivative of x, which is 1. 1 over x, natural log x.
So why is the derivative of natural log 1 over x?
This part here, or this
Yeah,
part? Okay, so first thing, I'm just thinking of this as natural log of something. Derivative is 1 over that something. But then I have to look inside here and take that derivative. And so the natural log of x has derivative 1 over this thing. So I'm really using that natural log rule twice, because what I'm taking the natural log of is another natural log. And then I did technically take the derivative of x, which was just 1. If that was a 2x, then I'd multiply it by 2. Question? The log of the log. All right, and you're going to have time to come back and work on these, so I'll be here to help you with these others. All right. Your natural log rule is right here. Natural log of u is 1 over u du dx. And then the last formula that's on here, this is when we have the log base whatever of a function. Now, it's base other than e, because if it's base e, then we call that natural log. So that for base e, we're using the natural log rule, but this is when the base is anything else. If it's base 10, base 3, whatever. Okay, so here's our setup. Log base a of u. The derivative is 1 over u, natural log of the base, and then take the derivative of u. This one's a little more complex. The formula is at the very bottom of this sheet. Okay. All right, so let's look at a couple examples. How would I know to use this one? Hello. Are you Christian? Okay, hang on 1 second for me. How would I know to use this rule? It's log. Not natural log, but log of some other base. Okay, so I rewrote it like this. Then using my rule up here, 1 over u. U was the square root of x, times the natural log of the base, natural log of 5. Then I have to take the derivative of square root x, which is all of that right there. Because I'm thinking of square root x as x to the 1/2. Bring 1/2 down, subtract 1 from the exponent. And then, can you see how I got from here to here? Okay, so all of this is here and here, but that 2 came down and that square root of x came down. What happened to that product? It became x. Ooh. Okay. Try for me, while I talk to Christian for a second, try 13 for me. See what you can do with that one. Plug in the formula. What did we get for this one? Tell me what your first step is.
1 over x squared.
1 over x squared. Natural log of 4 times 2x. Anything else? All right, can I reduce that? 2x over x squared natural log of 4. Yeah, one of those x's will cancel, right, on the bottom. So I just have 2 over x natural log of 4. Why do you think I'm putting natural log of 4 at the end there? Yeah, if I put natural log of 4 in front of x without parentheses, it's going to look like natural log of 4x. So you can put it in front, but just put it in parentheses if you do. Question? Okay, so those are those other missing formulas from the sheet. Okay, this next one. This is not on your formula sheet. But these are the steps we're going to take, and if you want to add those to the bottom of your formula sheet, you can. Let's work through it first, and then when you start on homework, you can add that if you want to. Okay, so why this isn't a formula is because it's a different step every time. It's when we have a function of x raised to a function of x. We don't encounter those very often, and it's a process, not a formula that we use. So, for example, what would that look like? X raised to the x. Function of x raised to a function of x. Sine x raised to the x. function of x raised to a function of x. Okay, so these are the steps. Take the natural log of both sides. Okay, so first step, I took the natural log of both sides. Just plop ln in front of it. Next step, use the power property of logs. Do you remember from your logarithm rules, if you have an exponent, you can bring it down in front as a coefficient. Okay, so what that does, it's very handy because it takes that exponent away so that you don't have a variable stuck in the exponent. So now I have this. Okay, next step after that, differentiate both sides. That means take the derivative, right? Okay, what is the derivative of natural log of y? 1 over y, then take the derivative of y, dy dx. Because of our natural log rule back here. Okay. Then, on the right, I have to use product rule. This is u times v. All right, there's u, v prime, plus u prime v. Look at this step. Is everybody okay with that? All right, next step. Multiply both sides by y. Okay, why am I doing that? Can you guess? Yes, I want to solve for dy dx, right? And it's got this 1 over y. Every time it'll have that 1 over y there. So to get rid of it, I have to multiply both sides by y. Okay, so that cancels out here and leaves just the dy dx. And then the very last step, replace y. Okay, so where I have this y sitting, remember y was x to the x. So the very last step, I just replace that with what it was originally. And that's it. So it's messy, it's different every time, but the same pattern will help us take care of it every time. Okay, so next one. Sine x raised to the x. So let's go through step by step. First step, take the natural log of both sides. Next step is use that power property. So this x comes down in front. Okay, next step is to take the derivative of both sides. Natural log of y is always going to be that 1 over y dy dx. I have to use product rule here. This is u, and all of this is v. Okay, so here is u, v prime, plus u prime. What size, Christian? XL? Gotcha. Thank you. That's u prime times v. Check out this and make sure you're okay with that. What do we think?
At first I was confused how you got the natural log of sine x on the other side, but then when it did product rule, so I kind of lost.
So that's 1 over sine x. Where does that come from? Derivative of natural log. And then the cosine is because it's the derivative of sine. Chain rule. Okay. All right. So this became x times cosine over sine. Oh, but what's cosine over sine? Cotangent. And then last step, or almost last step, multiply both sides by y to get rid of that 1 over y. And then replace y with whatever it equaled originally. Okay. All right, next page. Find the hardest looking one and we'll do it together. I'm going to guess which one you are going to guess. 17, you said? 18? What do y'all think? That's the one. I thought y'all would say 18. All right, well, you're going to get to do 17 in just a minute and get help if you need it. Okay, so power of x raised to a power of x. That's the one that doesn't have a formula. It's got the rule. Okay, so can you remember the first step? Natural log of both sides. Just plop it down. Natural log of y, natural log of x raised to the natural log of x. Okay, then what do I do? bring down the exponent. So that's using that power property of logarithms. I have natural log of y equals natural log x times natural log x. I have two options here. I could just write that as natural log of x squared and take the derivative that way, or I can just straight up use product rule. Would most of you do product rule, you think? Okay. So next step is to take the derivative. So this is 1 over y dy dx. Okay, u v prime. What's the derivative of v? 1 over x. Plus u prime, well that's another 1 over x, times v. All right. These are the same thing, aren't they? So don't I have just two of them? So I have 1 over y dy dx is 2. I'm going to make that 2 over x natural log x. Do you see where I got that? This is 2 1 over x natural log x. One of those plus one of those is 2 of those. But then I just made that 2 over x in front. And I could put 2 natural log over x if I wanted to. Next step, multiply by y. Get rid of that. And I'm going to come up here, dy dx. Very last step, replace y with what it was originally. So I have 2 over x natural log x times x to the natural log of x. Not usually on these. Usually these are just like find the derivative. Now e to a power, we will use that a lot. And natural log, those two will keep popping up. These others, not so much. Okay, and then the last page is the easiest of all. If you have a function that is raised to a constant, then we just use our exponent rule. Bring down the exponent, subtract 1 from the exponent. Okay, so for example, if I had cosine to the 7, I would bring the 7 down. Cosine is now to the 6. Multiply by the derivative of cosine. Okay, so we've been doing this one. Okay, but what if the exponent is something weird like square root of 3? Well, you still bring it down, and you still subtract 1, but if it's something that doesn't simplify, then we just leave it. Okay, so at the bottom, do any of those look bad? 21 maybe? Okay. All right, derivative is bring down that entire number times x, and now I'm going to subtract 1 from the exponent. It's just what? Square root of 2. And that's it. Because if I take that and subtract 1, then the 1's gone. Okay. So those are easy. You've been doing those. You just might get some weird numbers like square roots here. Okay. Last one really isn't even necessary. It's if we have a constant raised to a constant. It is just a constant. So a number raised to a power is still a number. So if you're asked to find the derivative of 3 raised to the pi, that's a number, isn't it? And what's the derivative of a number? 0. If you're asked to find pi raised to the e's derivative, that is a number raised to a number, which is a number, and the derivative is 0. So what would the derivative of these two be? 0. Okay? Yeah, those are easy. You got that one, huh? I guarantee if I put that, some of you would miss it, though, because you would try to make it hard. Okay, so your assignment, you've got 25 minutes, is to just go back and finish the rest that we didn't get to. Okay? I will help. Let me know if you need help.